Welcome all to the session on non-traditional machining and CNC programming. In the last two sessions, we have studied about machining, drilling, and milling operations. So those all the three come under conventional type of material removal process. As we have discussed in the earlier classes, that conventional way of material removal process is where the tool will be harder when compared to the workpiece material. Whereas non-conventional machining or non-traditional machining is the process where the tool need not be harder than the workpiece material. Like as we also have discussed that what are the different energies which we use. Like for example, the main difference is the tool will be harder when compared to the workpiece in a conventional machining, whereas in an unconventional the tool will be softer when compared to the workpiece surface. Whereas in conventional type of material removal process, the other difference is between conventional and unconventional is there the type of energy that we use. The type of energy that is used in a conventional machining process is mechanical type of material removal, where the tool will also always be in contact with the workpiece surface while the material is getting removed. So that is mechanical way of material removal process. Whereas in an unconventional machining process, there you can observe there are different types of energies that are used, right? Different types of energies, not only mechanical energy. Here we can also use chemical energy, electrical energy, combination of two or three energies, that is electrochemical, where we use electrical and chemical energy, and thermoelectric, where we use thermal and electric energy, and the other types are where we use light energy, that is by using laser beam light energy, and also by using electron beam we remove the materials. Now here coming to the unconventional machining process, that is we use different types of energies to remove the material from the surface. Now that is the other difference. And what are the other differences which we have seen in the last session? That is in a conventional type of material removal process, since it is only mechanical type of material removal, that is where the tool will be in contact with the workpiece surface. Since the tool is in contact with the workpiece surface, the amount of forces that are generated during the material removal process are higher. Whereas in an unconventional process, the tool will not be in contact with the workpiece surface. As the tool will not be in contact with the workpiece surface, the amount of forces that are generated in an unconventional or a non-traditional machining process will be much lesser. So by this what is happening, the as the amount of forces are produced are less, the amount of power generated or power required due for that particular process is also becoming less in the case of unconventional type of material process removal process. So now if you take the other type of process, uh, like the conventional process, and there like since the tool will be in, as the tool is in direct contact, and also large amount of forces are generated during the removal process, there we can see that the amount of material removal process, the amount of material removal that is happening during the process is much higher. The MRR rate, material removal rate, will be higher in the case of conventional type of material removal process. Whereas in an unconventional material removal process, the amount of material removal rate will be lower. So usually conventional type of process are used for initial material removal process. Since we can remove very less amount of material in an unconventional machining process, there since the amount of material removed is lower, the it is mostly used for finishing process. this type of process are used for finishing process. And also, since the material removal rate is lower, now these are considered to be much costlier. These are considered to be much costlier when compared to the conventional type of material removal process. So these are the differences between conventional and unconventional or non-traditional machining process. So now in this present slide, you can see the classification of modern machining process or non-traditional machining. They can be called as with any name, unconventional or non-traditional or modern machining process. Okay, so the classification of these process is given here. So now in a mechanical type, when the type of energy, these are classifications based on the type of energy that is used. So in a mechanical type, the material removal is by erosion process, where, like you can see here, the first one, like here you can see, for example, if you take a water jet. If you take a water where the water jet, when you impinge it, when it is coming through a pipe, and if you impinge it on the surface of any wall, or if you impinge it on any wall, when you impinge it on the surface, then what will happen there? There, the material or the water will be falling on the wall like a small droplet, right? So if you impinge the water at high velocity onto any surface, it exerts some pressure, right? So the pressure with which it is coming out will be much higher when it is used normally. Like when a highly pressurized, like if you close the nozzle opening of the pipe with your finger, when you close it with your finger and then impinge on the surface, so the pressure exerted by that high pressure water on the surface will be much, it has more impact when compared to the normal water, like without any pressure exertion, right? So highly pressurized water, like for example, if you take a tap, if you open a tap, and if you place your hands below it, so if you open the tap to the fullest and you place it behind hands below it, then what the water has, it has the ability to remove the dust on the surface of your hand, right? So it has the ability to remove the dust on the surface of your hand. In the same way, when a highly pressurized jet, if highly pressurized jet is impinged on any surface, it has the ability to erode that surface. Erosion is nothing but removal of a layer from the surface. Now it has the ability to erode the surface, like soil erosion. You see, like in soil erosion, it is nothing but removing a layer or washing off the layer from the surface of the sand, surface of the soil, right? So in the same way, when highly pressurized jet is used and impinged on any surface, it has the ability to remove the material from the surface. So that principle we use here. So in a mechanical type, we use erosion process. The material removal, or the mechanism by which the material removal happens in a mechanical type of unconventional machining process, is by erosion process, right? So here, what are the particles which are removing the material? Now erosion is happening, the mechanism which is happening is erosion, that is washing off the surface layer. Now what is that which is removing it? It is the high velocity particles. It is the high velocity particles. Now the example which we have taken is water jet, right? Even if you increase the pressure of the water and if you impinge on any surface, it has the ability to remove the layer from the surface, right? So the particles which we are using here is water particles. So at high velocity, the particles are coming and hitting the surface at a high velocity, right? So those are high velocity particles. Now in the same way, now the example we have taken is a water. Like in the same way, if you use air and a mixture of abrasive particles. Now the abrasive particles here are nothing but hard particles. Abrasives are nothing but the hard particles. Like in grinding we have seen, right? The grinding wheel consists of some hard particles. Or the example is the grinding stone, right? If you all might have seen grinding stone for sharpening the knife and all, we'll see. Now that stone consists of some hard particles in it, like silicon carbide. Now those are sand particles, right? So in the same way, we these abrasive particles are there are four abrasives, different types of abrasive particles. The mostly used ones are aluminum oxide, silicon carbide, uh, diamond, silicon carbide, diamond, and carbide materials. Those are used as abrasive particles, right? Those are the high velocity, those are the abrasive particles. They'll be mixed in air or they can mixed in water. Now this is only to increase the velocity of the particles. Now when you subject these particles, now along with, if you use only water, like what is happening there, if you use only water, this water has, you can pressurize the water, you can cut, like you can cut the material. Now only it is applicable to only certain soft materials. Now water, as the amount of strength of the material increases, it will be applicable only to a softer materials, water. But if these water particles, water is mixed with any sand particles or aluminum oxide or any other particles, when you mix them and then you increase the pressure of these particles, then what happens there? The amount of pressure exerted or the velocity of with which the particles which come and hit the surface will be much higher than compared to only if you constrain yourself to a water or air, right? That is the reason we mix it water. Like for example, you take, if you, if the same water which we have taken out of like coming out from the tap, if some sand particles are mixed along with the water, then what happens there? When those particles along with the water, when they are coming and hitting the surface, you feel that more velocity when compared to normal water which is coming out, right? So these particles will exert more velocity, they attain the same velocity as that of the water, but since they are harder in nature, the amount of pressure they exert on the surface will be much higher when compared to the water particles which are softer in nature. So that is the reason we mix these water along with some hard particles like aluminum oxide, silicon carbide, diamond, boron carbide, along with these particles. Now, these will be in the form of fine grains, very fine grains. Now, these particles are mixed along with the water and they are pressurized, and when these pressurized water, now the water or the air which we are saying, those two will be like a carrying the medium, they'll be acting like a medium which carry these particles. Now these particles will be hitting the surface, and when they hit the surface at that particular point, they exert some pressure, they exert or they increase the stress at that particular point, and they remove the material from that surface, right? So now, these are nothing but the high velocity particles. Now, high velocity particles which hit the surface and they remove the material in the form of erosion process. So, we use pneumatic, hydraulic pressure, the sources to increase the pressure of this. We use pumps to increase the pressure, actuators, all these are used to increase the pressure. And the different types of process which we see: abrasive jet machining, ultrasonic machining, water jet machining. So these are the different types of process. Now this is in the case of mechanical, where we use abrasive particles mixed with some fluid. It can be air or some water. Right. Now we'll see in detail what are the different types of process which come under this. And the next type is chemical type of material removal process. As we have discussed in the earlier session, that chemical is by mixing some chemicals, you place that workpiece surface which has got some rust on it, and then you place it in the chemical solution. Now after some time, due to the reaction between this oxide layer and the chemical solution, the material will be taken off or wiped off from the surface. Right. Now this is nothing but the bleaching powder. We use bleaching powder to remove the stains from the surface. Right. So in the same way, this is nothing but the chemical reactions will occur between the surface oxide layer or whatever it is, the surface layer will be when it comes in contact with the workpiece surface, it reacts with that surface and forms like salts, and material removal will be happening. So this kind of mechanism we call it as ablation process. This kind of mechanism is called as ablation process. So the mechanism by which the material removal which happens in chemical machining is ablation process. And then what is the environment? The media. What is the media which we use here? It is a reactive environment. Since we are using chemicals, it is called as a reactive environment. And the energy source is the agent which we use, the chemical which we use. And the different types of chemical machining, we call it as chemical machining process. And then we have electrochemical machining process. Electrochemical, the best example is electrolysis process, which you all have studied in your physics. That is, in an electrochemical electrolysis process, we have an anode and a cathode, which will be placed in an electrolyte. And when you pass the electricity, ion transfer will occur from anode to cathode surface. That is nothing but, this anode is nothing but our workpiece. Now this workpiece, if it is connected as an anode, from this surface the material will be lost from the anode surface, and it gets settled on the in the electrolyte as a salt, as a sludge. It will be settling at the bottom. Right. So this type of material removal process, we call it as, this is electrochemical machining process, where the material or the mechanism of material removal is happening mostly by ion displacement process. It is happening by ion displacement process. That is, the ions from the anode surface are getting displaced from the surface. That is ion displacement process. And the environment of the media which we use here is nothing but electrolyte. So in the electrolyte, that is where the electricity will pass from one anode to the cathode. Okay, so this is acting like a media. And here, what is the energy source which we are using here? We are connecting this anode and cathode both to an electrical power supply, so high current is used. So the process which we use here is ECM, ECG, electrochemical machining and electrochemical grinding. If we remove the grinding process, it is called as electrochemical grinding. Now, this is a combination of electrical energy and chemical energy. Both electrical and chemical are used here. And thermoelectric is where we use thermal energy and electrical energy. Both thermal and electrical energies are used here. So in this process, what we use here, we use plasma arc. Plasma. We convert the state into whatever the gases that we use, here we use gases, the gases will be converted in the plasma form, and it is used for material removal process. Or ions, the gas which is used will be in the form of ions, and then it will be impinged on the surface, due to which when these ions come and hit the surface, they at that particular point where this hitting of the surface will happen, there the material will be reaching up to its vaporization point. So for a, like whenever a material is heated, right, first the material will, when a material is subjected to heat, first the material will be heated, and then afterwards it will melt, and then afterwards it will vaporize. So these are the different stages of uh, material heated metal conditions, right? First it gets heated up, then it reaches up to its melting point, and then it will be reaching up to its vaporization point. So that is the plasma arc machining and ion beam machining, where we convert it into ions and then hit the surface. And then again we have is EDM process, electric discharge machining process. EDM process, electric discharge machining process. In electric discharge machining process, we use the sparks created by these atoms movement, electrons and ion movements. When the electrons and ions move from one surface to the other surface, these movement of these electrons and ions will increase the surface. Like as we have studied in arc welding process, there also when you connect a workpiece to a anode as an anode and tool as a cathode, and when you switch on, when it is connected to a power supply, then what happens, this movement of, due to the gap voltage difference between the tool and the workpiece, uh, there will be movement of these electrons and ions from one surface to the other surface. In the same way, here also the electrons and ions move from one surface to the other surface. The difference between there and here is that there in welding, the material will reach up to its melting point, whereas in EDM, due to high voltage, the material will be reaching up to its vaporization point. Since the material reaches up to its vaporization point, the material removal, we call this process as material removal process. Okay, so that is EDM process. Now here it is by vaporization. And then again we have, if we use light source, that is, for example, like everyone has might have used magnifying glass in your childhood, right? So when you concentrate a certain amount of light onto any surface, it has the ability to burn that surface, right? That is what you have observed. If you concentrate the rays of the light onto a surface, it has the ability to burn that surface. That is what we have learned from the magnifying glass experiment, right? So this also, laser beam machining is nothing but where we use a highly amplified light source is used. Like for example, if you take the normal light or a tube light and laser light. The difference between a tube light and a laser light is that here it is not unidirectional, multidirectional. The rays are, in a tube light, the rays are multidirectional, whereas in a laser light the rays are unidirectional with same wavelength. The rays will be coming out in the form of same wavelength. So that is the reason it is unidirectional and highly concentrated. So that is the reason, if that kind of energy laser beam is used, this will burn the surface, it will burn the surface. So that energy we use to remove the material from the surface. That is where when this light hits on the surface, it will vaporize and remove the material from the surface. And then that is by the media is radiation. By radiation process, the light comes onto any surface, and we use the source is amplified light. And then again we have ion stream, that is plasma arc material machining process. Plasma is nothing but ionized gas. So that gas is used to remove the material from the surface. So these are the different energies. Now if you take the conventional type of material, there we use only shear. The material will get shear from the surface. It is by the physical contact, and a cutting tool is used. This is the conventional type of material removal process, where only it uses only a mechanical energy. Whereas the other modern machining or a non-traditional machining process, they use different types of energies to remove the material from the surface. So that is the difference between a conventional machining and an unconventional machining process. Now, what is the need for this? What is the need for these non-traditional machining process? Now, in the lab, you're performing the experiments, you're doing the experiments. So, is there any need for you? Did any time you got this thought that I should remove this without I should remove the material from this without any contact. I should get the this thing and without any without any contact between the tool and the workpiece. Without that also you are obtaining the required job dimensions, right? What is the difference? What is the need for this non-conventional machining process? The need for these unconventional machining process arises where now, in the machining process, you are using tool. What is the tool which you are using? You are using a carbide tool, right? You are using a tungsten carbide tool and high-speed steel. High-speed steel is the tool, or mostly we'll go for carbide tools. So now, when you are using such kind of tools, now when it gets blunt, or if you want to machine, or if you want to produce those kind of materials, those kind of tools, how do you produce, right? So to machine those kind of materials, that is hard materials, high strength materials, there this unconventional machining comes into picture. These are developed mostly to remove the material or to finish the surfaces of hard materials and also brittle materials. Now, by using a conventional machining, can you machine a glass surface? No, you cannot machine a brittle surface. But by using a non-traditional machining process, you can machine a ceramic material, you can machine a brittle material, you can machine a hard material. So these processes have come into picture to machine hard materials, high strength materials, brittle materials, fragile materials. Now there this unconventional machining comes into picture. So now if you take, now as we have seen the classification of these different types of process, like we have the ultrasonic machining. Ultrasonic machining, water jet, if you take this mechanical process, ultrasonic machining, water jet machining, abrasive jet machining, all these three uses which type of mechanism to remove the material? Erosion type of mechanism. Now the mechanism is the same. If you see, the mechanism of material removal is the same, but we use different sources or different mediums to remove the material from the surface. The mechanism by which the material removal happens is the same, but we use different sources to remove the material. In an ultrasonic machining process, first process, there we use, here is the tool, this is the tool, and this is the workpiece surface. Right, whatever the shape that has to be produced, that will be given to the tool surface. tool will be a softer material here. Tool will be a softer like aluminium. Now this aluminium will be given the required shape, and then the workpiece will be placed, and in between these two we pour an abrasive slurry. Abrasive slurry is nothing but a combination of water and abrasive particles. Abrasive slurry is nothing but combination of abrasives and water particles. So that will be poured in between these two. And now this tool will be given ultrasonic vibrations. The tool will be vibrating at ultrasonic vibrations. Now as the tool is vibrating at ultrasonic vibrations, this tool will be imparting those particles, abrasive particles which are in between the tool and the workpiece. Now here in an unconventional machining process, we said that there will not be any direct contact between the tool and the workpiece. So in that case, here as this tool comes in contact with these abrasive particles which are in between the tool and the workpiece, those particles will also start vibrating at that ultrasonic vibrations. They start vibrating, and when they are vibrating at that ultrasonic vibrations, they go and hit the workpiece surface with that high vibrations. At high altitudes, they go and hit the surface. Wherever they hit the surface, at that particular point, there the material will reach or beyond its shear strength of the material. When a particular point comes and hits the surface, there the material will go beyond its shear strength, and then shearing of the material will be happening. At that particular point, the strength will be becoming more than the strength. The strength with which this particle goes and hits the surface will become more than the strength of the material. It reaches beyond the strength of the material. When that happens, the material removal will be happening, right? Crack propagation will start, the material will come out from the surface. So such thing will be happening in the case of ultrasonic machining process. Now you can see in a video. So here you can see this is the tool which has some projections. Those projections has to be given, has to come on the workpiece surface. This is the workpiece surface, and these are the abrasive particles. You can see a small balls which are the abrasive particles it with suspended along with the water, right? So this is ultrasonic machining process. The next one is water jet machining. Like if you take the applications of ultrasonic machining process, ultrasonic machining is mostly used for machining glass surfaces, ceramic kind of materials, highly brittle materials are machined by using ultrasonic machining process. And next we have water jet machining. Water jet machining, as we have discussed, highly pressurized. Now this is the nozzle out of which the water jet will be coming out, and it is subjected or allowed to impinge on the workpiece surface. So now this workpiece, as it is water jet, now as we have discussed, water jet has, now more the pressure you pressurize more, the more material removal happens. Since water is very soft, now this water is mostly used for machining Softer materials. This has applications limited to softer materials. Mostly you have frozen meat. Now those are cut by using this water jet. And aluminium, copper, these are the materials which are cut by using water jet. Now to increase the efficiency of this process, then a process called abrasive jet machining, like abrasive water jet machining, has been come into picture, which is a combination of both water jet machining and abrasive jet machining. In abrasive jet, we use same thing. Instead of water, we use air mixed with abrasive particles. It's same thing. It uses nozzle, pressurized air will be coming out, and these particles, highly pressurized particles, will hit the surface. And when they hit the surface at that particular point, stresses increase. If they go beyond the strength of the material will be lost from the removed from the surface. In that way, there will be number of particles which will be coming and hitting the surface. In that way, the surface will be uniformly removed. That is the reason, since number of particles are used, the surface removal, material removal will be uniform. Now here we are using air plus abrasive particles. That is abrasive jet machining process. Now to increase the efficiency of water jet machining, we instead of this air, we use water. Water plus some abrasive particles. Abrasive particles are mixed, and that is called abrasive water jet machining process. So in this particular case, we'll see a video related to this. That is a nozzle which we are talking about, and that is the jet which is coming out. Highly pressurized water jet mixed along with the abrasive particles. So that is a steel material. This is high speed steel material. By using this water jet, the profile is been cut. So these are mechanical type of process. So next coming to chemical process. Chemical, as we have discussed, by using chemicals, and you place that workpiece now wherever we require. Like for example, if you want to show your face only up to a certain part, you put a mask, right? Only the eyes will be visible, mouth will be visible. In the same way, wherever the machining has to happen, there it will be allowed to expose to the chemicals, and wherever the machining is not required, there we close that with maskant. Maskant will be applied on the surface, and by applying that you place it on the surface. Now that is chemical way of material removal process. And next we have seen electrochemical process, that is nothing but where we use electrochemical combination of, it is same as electrolysis process, where we use a tool, piece and electrode will be placed. Now in this process, if we place instead of this tool of a cylindrical shape or any particular shape, if you replace this with a grinding wheel, if you replace this tool with a grinding wheel, then it is called as electrochemical grinding process. Electrochemical grinding process, where the wheel will be rotating. Say all the other things are the same. Only thing is the tool shape will be changing. It will be rotating. Circular disc will be used, and along with that, the material removal process will be happening. Electrochemical grinding process. The tool will be in the shape of a wheel. That is called electrochemical grinding process. And next we have electrothermal process. Electrothermal process, where electro discharge machining process, like as we have discussed, there will be electrical sparks which will be coming out from the surface of one anode to the cathode by when you maintain a certain voltage gap. Now because of the voltage gap, this material removal will be happening due to the spark erosion process. This is also called as a spark erosion process. And then by using laser beam, you cut the surface, like for example is the one which we have seen. By using magnifying glass, you can even burn the surface. So that is laser beam machining. Electron beam machining, where we use high energy electrons to hit the surface, and they remove the surface. And then we have ion beam. We use ions to hit the surface and remove the material from the surface. And plasma beam machining, plasma gas is used. Gas in the form of plasma, that is used to remove the material from the surface. These are the electrothermal processes, where we use electrical energy and the material removal will be happening by thermal process. For example, you can see a video here in this particular case. So in this particular video, you can see the spark which is coming out. Here the tool is wire. The tool is a wire, is in the form of a wire, and that is cutting that much width, a large block. So even a wire can be used to cut the surface. So by sparks, by the movement of electrons and ions from one surface to the other, it removes the material from the surface, or it can even be used for cutting process. And this is a bi-radium process. So here you can see the chemical machining process. As we are discussing how the chemical machining process will be happening. So in this present case, he is applying the maskant on the surface by spraying. By spraying, the maskant is applied. And then depending on the shape, it is cut by using a scriber. Whatever the shape that is required, if the shape is not that complex, it is drawn, and multiple same kind of this thing is has to be brought, that will be cut. This maskant will be sprayed first, and then they remove the maskant from the surface, and then they, wherever the machining is required, there the maskant will be removed, and then it will be placed in the chemical solution. The main thing is this process is, it is a slow process, since no other energy except the chemical reaction between the surface has to take place. This process is a slow process. It takes time. So depending, like here, the depth that is required, how much depth that is required on the surface, that can be obtained by trial and error basis. Here it is not a particular depth which we can be obtained. So here you can see how the fine removal of the material is happening. You can see very fine depth, the material is lost from the surface. So that is how they check the depth of the surface. Fine slots can be obtained by using this chemical machining process. So these are the different types of machining process, unconventional machining process. And then again we have, next we'll be seeing CNC programming. Now before going to the CNC and CNC programming, just an introduction to what is CNC. CNC is computer numerical control. That is, now here in the lab, in the workshop, you might have seen, right? You have seen the lathe, you have used lathe, and it is manually operated. Whatever the lathe which you have used in the lab, it is manual operated lathe. But if the same thing is connected to a computer, if the same machine is connected to a computer, if it acts on a particular programming, then we call it as a computer numerical control, CNC lathe. It is called as a CNC lathe. In the same way, if we have milling operation, milling, all these operations or all these machines, if these are connected to a computer numerical control, then we call them as computer numerical control lathe machine tool, computer numerical control milling machine tool, all these things. So this is CNC, computer numerical control, where whatever the operations which you have done, the depth of cuts, the feed which you have given, all these operations which you have done, now all these can be performed using a CNC program, by using a CNC program. Now, before going to the CNC program, as we know, every program needs some codes, right? The machine will not understand our own, whatever the language we know or whatever the language we write. So, whatever it understands is in the form of a code, right? In the same way, the CNC lathe also has a certain language or a code that has to be provided by us. Now, whatever the program which we write, whatever the commands which we give to the computer, those will be in the form of codes. Now, there are two kinds of codes which we use. Well, to write a program, we use two codes, that is G code and M code. We use G codes and M codes. G codes are nothing but the, how we'll be telling, by using G code, it will tell what are the operations that are to be done, how the operation has to be done, where the tool has to move, in which path it has to move. How the tool G codes will tell about the operations that are happening. That is how the tool has to move, where the tool has to move, in which path it has to move. This is the information which will be given by G code. Whereas if you see M code, right? If you have M codes. Now G codes start with G. As you can see on the screen in this slide, present slide, G codes will start with G, capital G, 00s, 01, 02, like that. In that way, there are certain codes which are given, which are predefined. These are predefined, as we have in programming also, right? Predefined functions, like that. In the same way, here also we have predefined codes. Now, if you use a particular code, it will be doing that particular operation. Right. So we have G codes which start with G, capital G, and we have M codes. M codes are nothing but miscellaneous codes. M codes are nothing but miscellaneous codes. They they give the machining conditions, like whether the machine has to start or stop, whether the coolant has to start or whether it has to stop, or if you have to end the program. These all these miscellaneous things will be given by the M codes. G codes tell about how the tool has to move, where the tool has to move, and in which path it has to move. Whereas M codes will tell about the miscellaneous things, that is, when the program spindle has to start or stop, whether the coolant has to be on or coolant has to be off, whether the program is on or whether the program has to be stopped. So these are the codes which will be given by M codes. So mostly when you write a program, we'll be writing in the form of G and M codes. That is what you have to remember. So all these codes has to be remembered. Not all, most of them, like you will not be using much as a part of first year workshop. Only very less codes. The basic program will be seeing how to write a basic program for the operations which you have performed in the lab. Like you have done a step turning operation, right? Step turning operation you have performed in the lab, and you have performed taper turning. uh, like it will be seeing how if the cut has to be in a circular way, how it has to be done. Now a basic small example we'll be taking, and we'll be writing a program. Now to get that particular operation, what how the code has to be written if you are doing the same operation in a CNC lathe, right? So these are the codes which have to be remembered. Next, so for turning for lathe, there will be lathe machine tool, there will be certain codes, and for milling there will be certain codes. Now there will be some variation in the codes when you come to the milling operation and lathe operations. So here we'll be, in this present example we'll be seeing a machining of lathe turning operation. How the codes will be how the program will be written by using a lathe when you are going on a when you are doing the operation on a lathe. So this is the job which has been given here. Now all the dimensions are in mm for this particular job. Now this is the initial cylindrical rod which is of 45 length and 40 diameter. This is the rod which has been given, and this is the final output that is required. Now this is the final output, like there is a step turning operation, there is a taper turning operation, and also there is some curve like section that has to be obtained. Now, if my output is of this, if my output is of like this, now how I have to write the code, right? So this is my initial job, cylindrical rod which is given to you, and my final output should be this one, the below one, bottom one. So now for this, now since in a turning operation you might have observed, only the thing is the most important, if you give certain, only if the tool moves only half the distance, then the whole distance diameter is obtained. Like for a 10 diameter reduction, for a 10 only this tool that has the tool should be moved only up to 5 so that this whole circumference or whole diameter 10 diameter can be obtained, right? So for this we'll be considering only half of the section. To write the program, for this profile we'll be considering only half, right? Now for the most thing which has to be remembered is, in a lathe the positive, you can take this vertical one is x-axis and the horizontal one is the Z axis. That is where we give the feed. This is the feed direction, Z is the feed direction, and X is the perpendicular direction, right? So now here this we are considering half of the profile. We are considering half of the profile that has to be obtained. Now in lathe you have to remember one more thing, that is we'll be giving the dimensions or the coordinates in terms of diameters, not the radius. Even though we are considering here this point, now we'll be giving in terms of diameters, right? So for this particular thing, 10 is the diameter, right? For this particular step turning operation to this end, 10 is the diameter of this section. Now here, while writing the code, while writing the coordinates, so first when you get the profile, first thing what you have to do, the tool has to be moved from one point to the other point. How will it identify? Now here we are giving coordinates, right? X and Z coordinates. We have to write these different points in terms of X and Z coordinates. We have to write different points of this particular thing in terms of X and Z coordinates, right? So we define all these different points, from where it has to move, from where it has to start. Now all these points will be defining, right? We'll take for this. So to obtain this cross section, this output, first we take half of the section. First we take half of the section, and then we'll define these different points where now the tool has to move. Now we have to tell. Now as we have said, now we have to give. We have to know where it has to move, how it has to move. Now to tell the tool that it has to move to this point, this point, this point, this point, how it will know? It will be knowing only when we define these particular points. Coordinates, in terms of coordinates. What is this point? What is this point? What is this point? So first we have to define the coordinates of these different points, right? So coordinates have to be written. That is in terms of diameter. Z is always it is taken as in here in this particular operation. It is in terms of diameters. We take in terms of whether we are writing for a half section or a full section. We'll write in terms of diameters, not the radius. Okay. So if you first what we have to do, we have to know the reference point. So as we have said, the total distance is 45. The total distance is the total length of the job is 45, right? What is the total length? It is 45. And then what is the total diameter? It is 40. Total diameter is 40. So now first to start any program, first we need to know the reference point, from where the tool has to, wherever the tool might be, anywhere in the circumference, in wherever it might be present anywhere. First we have to come to a reference point. So here we take the reference to be 1 mm above, 1 mm above and 1 mm just behind. So here I am taking the reference point to be, since it is 40, the total length here is 40. So I am taking it just 1 mm above, 41, and we are defining this point to be 0. Where we are starting this point is 0. That is 1 mm, just after that it will be 1. Since if you define this point to be 0, when you come to this side, if this is 0, then this is positive z direction. So after 0 you get 1. If you go after this, you get minus 1. Right? This is minus z direction. You can see from the axis. So if I take a point, reference point, so at any point, I am taking here it as 1, 41 and 1. 41 is x, which is the vertical dimension, and 1 is z dimension, that is just after the origin point. Right? Then after I define the reference point, Then I define the next point, that is the first point where it has to start on the workpiece surface, that is at the center axis. So that I am defining it as, for our convenience, I am defining it as A00, origin point. This is the 0, 0 point. And then after that I am defining this point, that is my A. Now what is this point? Now this point will be 10 mm in the x direction. You can see here. Now I'm taking, this is 10 mm. So this is x coordinate. So 10 mm in the x direction, and what is the z coordinate? It is 0. Same axis. So 10 and 0. Now what will be this point? C point. If I define this as C point, what will be this point? Now the tool has moved from this to this. Now what will be this point? It is in the minus z direction. So it is 10 comma minus 10. What is C point? 10. Same. X is the same. Right? Same height. So x is the same. 10 comma minus 10. And what will be this point? D coordinate? It is, we have moved just ahead. That is, what is this? We have defined here. What is this diameter? It has to move to this point. So if I take this as 20, then what is this point? It is 20 comma minus 10. Same, 20 comma minus 10. And from here it has to move to this point, E point. If I define this as E point, now what is that point? It is in the same height, that is 20, and the coordinate here is minus 20. It has moved 20 this side in the minus direction. We are writing it in the terms of, like here you can see this is positive x and this is minus z. So minus 20. Right? So in the same way, if you write F point, now here the radius we are taking for this curved section is 5 mm reduction in the radius, curve with a radius of 5. And then if you define the point F, now F is defined. Now what is this diameter? You can see from this figure, it is clear this point is 30. The diameter is here, it is becoming 30. So our height is 30. And how much I have moved? I have moved 5 radius. If I take a quarter circle, it is 5. This much I have moved. So it is minus 25. From this point I have moved minus 25. Right? So from the origin, if you consider, it is minus 25. So F is 30 and minus 25. And in the same way, if you take the next point, 40, what is this diameter? You can see from this figure, it is 40 diameter. So 40 and minus 35. We have moved minus 35. So from here, 10, 20, 30 and 5. So we have moved to this point. So minus 35 is the coordinate. And the next coordinate, which is H, which I am defining it as 40 and minus 45. So it is 40 and minus 45. Right? So 40 is the diameter, final diameter. It has to come to this point. Is that clear? So in this we are defining the different coordinates. So first you have to define the coordinates, right? So that is by giving one origin point. Based on this point, all these different points are defined, right? This kind of representation of the points based on one initial point, one reference point, we call this as absolute mode of defining the point. Absolute mode. This is defined as absolute mode, where one reference point is taken and based on that we define other points. Now if you take all these points, those are defined based on this, taking this as the reference point. Now minus 1, how can say this is minus 45. Since this is 0, this dimension is becoming minus 45. Till here it is coming it as minus 45. In the same way, we are defining each point, whatever the point you take, C, D, E, F, G, H, whatever you have taken, all these are defined based on this point, one reference point. Now this is called absolute mode. This is called absolute. So there is one other mode, that is incremental mode. There is another mode called incremental mode, where this for to write this point, my for to write B, my A will be my reference, and to write C, B will be my reference, and to write D, C will be my reference. That is, the reference point will be the earlier point. The reference point shifts in this case. In an incremental mode, the reference points will be changing. The reference point will be changing throughout the program. That is, to write an after point, the reference point will be the earlier point. That is, the reference point will be changing throughout the program, right? So that is, now if you take the same thing and if you define B point with respect to A, it is 10, 0 in an incremental mode. Now see how it will be in an incremental mode. From B, how much is changing? Nothing is changing. So it will be 0, minus 10. It will be 0, minus 10. Since 10 is not changing, right? My reference point is this one. So from this point to go to C point, if this is my reference, what is changing? This is not changing. So this will be 0 and this will be minus 10. Right? And if I want to write D point, what is changing? My minus 10 is remaining the same. Right? This is same vertical line. It is staying in the same point. So same point. So it is, how much it is changing? 10, 0. It will be 10, 0 because this is 10. From here it is moving only up to 10. Only 10 it has to move. So it will be 10, 0. This is incremental mode. Since already 10 has attained, now from this 10, it has to move only 10 more. This is my reference. 10, 0 is my reference in the incremental mode. So from here it has to move only 10, 0. So this is the incremental mode of writing, where to write D point of this particular section, earlier point will be my reference point. So this is incremental mode of writing. Incremental mode, where the reference points changes throughout the program. Whereas in an absolute mode, there will be only one reference point. Based on that, we define the other points. That is absolute mode. Right? So in this particular case, now first when you define the points, you should be clear whether you are using an absolute mode or incremental mode. So now that has to be defined, that has to be given as a code in the program when you are writing. So that I'll be telling you how you have to mention it, but for this program we are writing absolute mode. We are writing absolute mode. We are using absolute mode. Right? So for this, I'll be writing a program. So now these are my different points, A, B, C, D, E, F. These are my different points and this is my reference point. So these are my coordinates. So now when I have to write an axis I have taken, now first I have to start the program. So now in this, the first line, N00 defines the line number. There will be, when you write a program, there will be different lines. Now the N00 is nothing but it doesn't add in the program any operation. It is just the representing the line number. N01, N00, N01, N02, N10, N11, you just follow a certain pattern. Some multiples you use n0 0 n05 n10, like that you just follow. It represents the line. And then if you take G90, now what is this G90? G90 is nothing but if you go to the codes, here, you can see G90 is nothing but absolute command. Now since as I have said, we are using absolute command, that is with respect to one reference point, we are defining the whole. Based on that, you have to write. The system should know which command you are using, right? Which mode are you using? So for that, for the system to know it, we have to write what is that we are using, absolute mode or incremental mode. If you define the coordinates based on one reference point, then we say it as absolute mode, and you have to mention it as G90. Or if you write in the incremental mode, if you define the points in terms of increment, then you call it as incremental command. If you define the points in incremental mode, then you give G90, right? So absolute mode command, whether you are using an absolute mode or incremental mode. So for this present program, we are using absolute command, absolute mode. So that's why we have to mention it as G90. Then after that, so G90 and G71. If you go to the codes, G71 is nothing but turning cycle. Here we are using turning operation, right? So since we are using turning operation, G71 tell that it is a turning cycle. So first we have to define what is the mode which we are using, whether it is incremental mode or absolute mode. And then you have to tell the system, see a computer system, that what is the cycle which we are going to do, whether it is a turning cycle, drilling cycle, boring cycle. There will be, for each cycle there is a certain code which is given. So in this particular case, we are using a turning cycle which is given by G71. And then we have G21. Now what does this mean? Now we have defined all these points, right? 10, 20, 30, 40. What are these? Whether it is in inches or in mm. The system should know. So to know that, first we have to mention what are the units. First we have to define the units. So G21 will tell the units, all the dimensions are in mm. Or G, there is other code which will tell that all the dimensions are in inches. So if it is in inches, you have to give the other code. If it is in mm, you have to give G21. So based on the dimensions, first you have to define the dimensions. Now based on that dimension, now you have to define how the feed is, whether you are giving in mm per revolution or mm per minute. What is the feed? How you require the feed? So G95 will define the feed in mm per revolution. G95 will tell that the feed is in mm per revolution. Now after defining what it is, and you have to tell how much it is, how much feed that it has to take. So we define F is 1 mm per revolution. F 1.0 means 1 mm per revolution it will take through the program, right? So this is the first line. So N represents the line number, G90 represents what is the mode which we are using, whether it is absolute or incremental, and what is the cycle which we are using, G71, whether it is a turning operation you are doing, a boring operation or a drilling operation, what is that you are doing. And then after that you have to mention how the units are, whether they are in mm or inch, how the units are defined. And G95 will tell how the feed should, whether the feed is in mm per revolution or minutes per mm per minute, how it is meter per minute, what is the feed, what are the feed units, right? So the first line should contain these. Okay, it will first we have to, like, for everything first we have to set the environment, right? To start anything first you have to set the environment. In the same way, how, what is the base things, what is the minimum things that the system should know before we go to the actual program, machining program. So these are the things which we have, which it has to be given in the first. So what are the units, what is the mode that we are using, what is the how units, mostly feed units we have given. Next, in the next line, where we have to, after giving the mode, after giving the feed, how it has to be everything, then we have to start the machine, right? So miscellaneous codes are mainly meant for the machine. So M03 is nothing but spindle rotation clockwise. So M03, which represents the spindle rotational movement, M03 clockwise, and S is at which speed it has to rotate. Now we are rotating the spindle, right? We have started rotating the spindle. Now at which speed it has to rotate? So 1000 rpm. The 1000 we have given. So clockwise rotation of the spindle in 1000 rpm is the speed at which it will be rotating. And then M08. So after you start the spindle rotation, then what you have to do? You have to switch on the coolant. So during the machining, we have to switch on the coolant. M08 is coolant on. So all these things you will be getting in the list which has been provided in the previous slides. Now M06 is the tool change option. Now earlier you might have done some operation using some tool. Now you have to take a particular tool. Now in a CNC lathe there will be a machining center where number of tools will be placed. Any tool can be placed, like it can be a drilling tool, or it can be a boring tool, or it can be a single point cutting tool. In that way there will be different tools which will be placed in different slots. So based on where are for this particular operation, what is the tool that has to be used. If it is a single point cutting tool, then what if in which slot it is present. Now each tool will be given T01, 2, 3, 4, 3, 4, 5, 6, like that. So in that way, what is the tool number? Now this can be anything. For this example, I have taken it as T01. If I take that in T01 is the tool which is where single point cutting tool is present, right? So first we have given the background, what are the units, we defined it, what is the mode, and then in the second line we started the uh, machine, that is we have provided some speed to the machine, how it has to rotate, whether it has to rotate in the clockwise direction or an anti-clockwise direction. M03 clockwise rotation. Then after giving the command at which speed it has to rotate, so we have given 1000 rpm. And M08, which is nothing but the coolant has to be on. And then we have in this also we have different, whether you need a mist coolant or a flood coolant, what are the different ways of providing the coolant. So based on that different codes are present, right? Based on that you can select based on the operation which you are performing. And then you have the tool change option. M06, well, what is the tool? If it is another tool which is placed in the slot, then you have to go for the tool of the required for this particular operation. So tool change option. And then after that we know the difference point. So the tool might be anywhere in that zone, right? In the inside that inside the lathe, it can be present anywhere. So here if it is present in the slot anywhere, now it has to come to the reference point. So from first it has to come to the reference point. So now the next code is, the next one is G00. G00 is nothing but the rapid traverse. Now here the tool need not move in a slow pace or slow motion. So wherever it is, you are telling, you are giving the command saying that it has to come directly to this point. So by rapid traverse, it comes very fast. By a rapid movement, it comes to this reference point. Whatever the point which you give, that is x41 and z1. So to this point, it comes rapidly. And then again, this is the point it has to, so from this point, it has to move, come to this reference point or the starting point of the machining. So notice that it is called as 0, 0. So now we have to, so from here it moves in a linear interpolation. Now you can see linear interpolation where the tool moves linearly, right? So linear move interpolation is nothing but it moves straight in a straight line motion. It moves in a straight line motion. So that is linear interpolation. By using linear interpolation, it moves straight to this point x0 and z0. So it comes to this point now. So from here, from this point it has come. So from this it has to move to this point, right? So next B point it has to move. So how it has to move? It has to move in a linear motion. So what is the code which we have to use? We have to use MG01 is the code. Now unless and until you mention any other code, unless and until you change this G code will be active, right? There is no need to mention G01 here. In all the lines, wherever the linear motion is there, once you have activated this G code, no need to mention it in all the other lines, right? Sorry. So unless and until another G code is activated, this will be in activation, right? So now no need to mention Z01 all the time. So only it has to move in a linear fashion. So from A point to it moves to the B point. So X10 and Z0, it has to go to this point. Then from there it has to move to C point. How it has to move? It has to move in a linear path. So we use linear interpolation. So G01 is the code. So what is in activation? G01 is in activation. So no need to change the code. So next line is X10 Z minus 10. So from here it moves to this point, minus 10. And then again it has to move to D point. Now how it has to move? It has to move linearly. So it will be moving in a linear fashion, that is x20 z minus 10. So in that way, all these points will be, so we'll be defining all these different points. So z01 will be active, so it will be moving in this linear fashion till the required dimension is obtained. It will be machining the surface. So in that case, now the next F point, if you take this F point, what is this path? It is in a circular motion. Like if you observe this from E to F, it is circular. It is no more linear. So the G code will be changing here. So now what is the G code for circular motion? Now in circular also we have two codes, G02 and G03. G02 is circular interpolation clockwise. Circular interpolation clockwise. So it will be, if it is a clockwise movement, then we call it as a circular interpolation clockwise. So if it is anti-clockwise, like this, if I have a curve of this shape, like this, then it is counterclockwise or anti-clockwise. Counterclockwise interpolation. So circular interpolation can be clockwise or counterclockwise. So here what is required? We require a clockwise interpolation, right? So what is the code we have to use? We have to use G02. Z02 is circular interpolation clockwise. If you give Z03 instead of Z02, you get a curve like this, right? So what is that? Here one more thing. Since it is a circular interpolation, you have to define the radius. You have to mention the points where it has to go. So this is the point, F point, it has to move 30 and minus 25. And what is the radius? So the radius is 5 here. What is the radius it has to take to reach to that point? So it is R5, right? So clockwise in circular interpolation clockwise, Z0 to X30, Z minus 25 and 5 is the radius. This is the extra thing which comes in circular interpolation. So we have to define the radius. And next from here, now we have this one, tapered section. If you see, this is tapered section. Now in this tapered section, how it has to move? It has to move linear. Now this is also a linear movement. Only thing is the feed is changing. It is moving. The feed is it has to get a angular motion, right? It has to get a angular motion to reach this point, right? So now here it has to move linear. So now what is the code? Here the G code active is circular. So we have to change the G code. So the next line, which is Z01, is a linear interpolation, and you will be defining the points. So for tapered also it is same as step section. Only thing is the point. You have to mention the different points. Based on that it moves linearly. Next is it has to move linear, that is Z01. Same G01 is active, so X40 and Z minus 45. This is the next line. So from here it has to come to G00, X41 and Z1. So from here where it has to go, we will be moving it to we will be bringing this tool from here to the reference point. Again we will be moving that rapid traverse Z00 to the reference point. G28 also you can use, not with this, G28 where it moves to the reference point. So it comes here now. Now after this, what you have to do is the program. We have to switch off everything, right? So what we have to do, the next this thing we have to, M09 is the spindle coolant off. M09 is coolant off. You have to switch off the coolant. And then M05 is spindle stop. You have to stop the spindle. And M30 is end of the program. So you have to switch off all this. You have to switch off the coolant. You have to switch off the spindle. Stop the spindle. And M30 is end of the program. So this is how we write a program, CNC program, by using this. I hope you have understood this program. If there are any queries related to this program, understanding of the program, you can post it in the classroom. Okay. Thank you. In the next session, we'll be studying about solid state welding process, right? Thank you.